Hey everyone, this is Divya. I'm a product manager in Azure Logic Apps, and today in this video, I want to show you some new capabilities that we have recently released that further streamline building agents that use your company's data. Grounding agents in your company's policy or data is probably one of the most foundational steps in building agents that participate in companies' business processes. And this is equally relevant and applicable regardless of whether you're building autonomous or conversational agents. In this demo, we are focusing on conversational agents, but you can do everything that I'm showing here with autonomous agents as well. So in this demo, we'll go through three main steps. First, we'll create an index in Azure AI Search vector store to define the structure of our data. Next, we'll ingest a document in the vector store. Finally, we'll build an agent that would query this vector store. And this is where we'll go into new capabilities we have added in the AI search connector for vector search. So, as a first step, we are going to create an index in AI search that also supports a vectorizer. And here I am in Azure Logic App Labs, and we are going to follow step by step, directions in the document here to create the index. So for that, you go into the extend agents functionality and add knowledge using AI search with integrated vectorization. So here we have all the steps, and we are going to follow the part one, create your AI search resource and then create the index. So before we go into the creation of the index itself, let's take a look at the index schema that we are going to use. So this is the index schema. Of course, you can change it based on your specific needs. It has the name, and then it has a couple of fields defined in the schema. And lastly, it has vectorizer and the details for that vectorizer. So some of the things that you would certainly have to populate before you use it are the details of the Azure OpenAI resource that you plan to use. That would include the resource URI, API key, and then model name information for that instance. So here I have the AI search instance, and we'll go ahead and create a new index. I'm going to choose the add index with JSON option. And for the JSON here, we'll go back to the schema that I was showing you before, and we'll copy and use the schema. So I'm going to use the schema as is, but you may want to change the name if as per your needs, or any field that you want to add or update. We do have to provide all the OpenAI parameters here. So here is the Azure OpenAI instance that I'm going to use. We'll use the endpoint and the key from here. For the deployment ID and deployment model name, you go into your OpenAI instance and go to Foundry from Overview, and then you can go into your deployments. You do need to pick a model that's an embedding model, and so here I have deployed this embedding model, and we're going to copy that. In my case, both the name and the model name are same, but if that is different, then you need to pick the values appropriately. All right, now that we have everything, we'll go ahead and save it. So the index has been created. If we go ahead and look, you will see the fields that were in the schema. There is an ID, name of the document, the content of the documents, and the embeddings corresponding to the content. In the vector profiles, you will see the vectorizer associated with that index. At the moment, since we just created the index, it has no documents ingested. So that would be the next step, that we go ahead and ingest documents into this index. All right, so to ingest the documents in the AI search index we created, I'm going to use a Logic Apps workflow. And this is what the workflow looks like. It has a trigger for Azure Blob Storage. So when a new blob is added or updated, this workflow will get triggered. We read the content from the blob. Next step is to use this parse document action to parse and tokenize the document content. Then we use the chunk text action to create the chunks or the tokens from that document. And the next step is to generate the embeddings for that content. And here we are using the so again here we are using a model that supports embedding and also the output of the previous step. This is the step where we map the document data to the schema that we had created in the AI search. And the final step is to ingest or index this document into the AI search index. So as you can see here, we are choosing the AI search index that we had created initially and providing the input and providing the output of the previous step. Yeah, this is our policy document that we'll use when we create the agent. So the document that we just uploaded is a health insurance plan catalog that has details about several plans, claim codes, what's covered, what's not covered, and so on. So that's what we'll use in our conversational agent to help employee understand the differences between the plans and ask any questions on them. All right, so now we'll go ahead and create a conversational agent. And the purpose of this agent is to help employees understand the different benefits they have in terms of health insurance plans. To create an agent, we'll go ahead and add a new workflow. And here we have a couple of options. Gi- Given we are creating a conversational agent, we'll select that and provide a name for it. So here is our workflow with A to A trigger. All right, so now let's configure the agent itself. So here we can choose one of the existing connections. So I'll go ahead and do that and then choose my deployment model here. And then we need to provide system instructions for the agent. We give system instructions here, and then next step is we need to add tools or rather knowledge source for this agent. So now we are going to search for Azure AI Search action. AI search. We want, because we are on Logic App standard, we want to use the built-in connector. So here are all the operations, and the one that we'll use is search vectors with natural language. So this is a new action that we've added, using which you can search vector store, AI search vector store with question in the natural language. Before, if you had to do it, you had to do a couple of steps. You had to take the query in the natural language, generate the embeddings for it, and then use an operation like search vectors where you would provide those embeddings as an input. But now with this, uh, it becomes very easy, because now you can provide the query via agent, which can come in as a natural language. So here I'm going to select the index that we had created, which was enterprise data, and then the text that we want to search. This can vary based on the questions that the user asks, right? So here we want to use the agent parameter. um, so that will be our search text and text to search. I think the default name and description looks fine to me, so I'll go ahead and use that. Agent parameters basically allow you to indicate whether a value for a certain field is being provided by the LLM versus the developer. So here we are indicating that this value for the search text will be provided by the LLM. Now, something else that we are configuring in this action are the fields to select from the output. So by default, when you do the search, the response also includes, remember the schema that we had defined. So the response will include everything based on that schema, including the vector embeddings. Everything from this response will be provided to the LLM by default. So what we are trying to do here is pick the fields that are most relevant. So so in this case, we are essentially excluding the field that has vector embeddings, because we want to optimize on our token usage, and the embeddings are not really adding any value here. So I have only chosen the name of the document and the content, and those will be then selected as an output of this action, which then goes to the LLM. All right, so now let's try this agent, and let's go ahead and click on chat. So here you can see that the name of the agent and description is what we had configured in the trigger. And now let's go ahead and ask some questions. So here we can see the response from the agent. It shows a comparison of all the plans, and you probably noticed that we support streaming with this conversational chat, as well as multi-turn conversations. So let's go ahead and ask some more, follow-up questions. All right. So and now ask some specific questions about the coverage as well as the claim codes. So here is the run history for the conversation we just had. And through run history, you can see all the iterations of the agent loop and everything that happened in each iteration. The decision making that LLM did, the tools it called, and even for each tool, you can look at the inputs and outputs. All right, so this brings us to the end of this video. Hope this was useful. If you have any questions, feedback, or feature requests for us, please do fill this form and reach out to us. We would love to connect with you. Thank you again.